welcome to a video looking at shortcuts to proving triangles are congruent, part 1. So in class we talked about how congruent triangles, let's say we have two triangles. Actually, we can make some shapes that look pretty nice. I'll make two triangles, copy paste, makes it easy. Okay, so then we can erase this ugly thing that I just drew. Okay, so if we need to prove that two triangles are congruent, we need to show that all three pairs of sides are congruent and all three pairs of angles are congruent. And that's a lot of stuff. That's 6 pairs of things. So we have 4 different shortcuts that we're going to learn that will help us speed this up. All right, so the first 2 that we're going to look at are SSS and SAS. SSS, the first one, stands for side, side, side. And what it says is if 3 sides of one triangle are congruent to 3 sides of another triangle, then those triangles are congruent. So that's where the side, side, side comes from. We've got a pair of sides, that's one S, another pair of sides, that's the second S, and a third pair of sides. So what this shortcut is saying is that if that's all you have, are the sides are congruent, you don't need to know anything about the angles. That is enough to show that the triangles are congruent. So it cuts our list of ingredients in half. We only need to see that all 3 sides are congruent. All right, let me show you another example off to the side here. Let's say that we have this picture. Okay, we saw some things like this where they're sharing this side in the middle. And let's say that we have M here. We'll call this A, B, and C. And let's say that we know that M is a midpoint of AB. And then they also tell us that AC and CB are congruent. Is that enough to use side, side, side? The answer is yes. If M is a midpoint, then that means that AM is congruent to MB. And then also remember that if we have a shared side like we do in the middle, it's congruent to itself by the reflexive property. So that one comes up a lot in these proofs. So just get used to it now. All right, let's look at side angle side now. But first we need to get to a definition. And that definition is an included angle. Okay, so what is an included angle? Well, it's when you're talking, so in a triangle, okay, it is an angle in between 2 given sides. So 2 sides that we're talking about. Okay, so I think an example is going to be the best. So you're talking about a triangle, and let's say we're talking about these 2 sides. Okay, the included angle is the one in between. So that is the included angle between these 2 sides. All right, let's look at a non-example. So let's say we have a triangle. And again, let's talk about those 2 sides. Okay, the included angle is not this angle. In fact, that is called a non-included angle. Basically the opposite. And also, this one right here is also a non-included angle because it's just not this one, the one that's in between. So side angle side must include a non-included, or sorry, an include angle. So by looking at the terminology here, we have side, 2 sides, And then the word angle is deliberately in the middle because the angle is going to be in the middle. Okay, so let's read this. If two sides, okay, and an included angle of one triangle is congruent to two sides, and the included angle of another triangle, then the triangles are congruent. That included angle part is really important because if it's not an included angle, it doesn't work. Okay, so here we're talking about this side is congruent to that side, and this side is congruent to that side. So those are the sides that we're talking about. So our included angles have to be A and D. Those are the ones in between the sides. All right, and if it's not those two angles, then it doesn't work. It's not true. So there is no such thing as side-side angle. Okay, let's just get that out of the way right now. Side-side angle does not work. Okay, only side angle side works. All right, that's it for part 1.